I'm Pavel, and today I'm going to talk about implementation of DDoS attack. In my previous video I had basic introduction what is DDoS attack and why it's dangerous. Today I'm going to talk about what is the actual implementation of DDoS attack. And so, of course, you watched many videos, many movies about hackers and like bad guys using computers, black screen, with greenish symbols on them, like a Matrix movie. But what is the point? How attack is implemented? Like, is it some magic packets which immediately knock down your network? No. So we're going to talk about very simple stuff. So one of the main sources, one of the, I would say, most powerful things in any DDoS attacks, it's still, again, it's all standard packets, network packets. When I'm saying packets, you need to be specific about which level we are talking about. And so for our focus on volumetric DDoS attacks and attacks against telecommunication network, we need to be more specific what kind of traffic we are looking at. So, and for telecom networks, most dangerous attack types implemented using levels 3 or levels 4 attacks. That's simple. So it's very unlikely that you will see some complicated HTTP request, like maybe even implemented using sophisticated and modern protocol like HTTP3, using for attack vector against your carrier-grade network. That's not how it's implemented. It may be one of the steps of very sophisticated attack against your infrastructure, just to maybe divert your attention from main source of intrusion and keep your engineers busy with DDoS attack. But it's not something as power which intrudes in your network first. So, and most of the cases, what you will see when you're on TCP dump during DDoS attack, it's just packets. It's just IP packets. Which IP packets? We have two protocols, IPv4 and IPv6. I would consider, according to, because in Fastnet we have a really great customer base. Like we have around 25,000 of confirmed deployments for both versions of Fastnet. So we have great visibility about attack landscape because we are talking with customer on constantly basis every single day our support team, and I'm personally talking with customers like what is their problem, what we can do, and what is their problem right now. And IP attacks using IPv6 protocol are not that rare. It may be 1% of all attacks. It's hard to say a specific number, but they're not. It's not zero. It's definitely not zero. You cannot say okay, I don't care about IPv6 protocol, and you must. It's modern protocol. You need to have it in your network. I mean, you must, because it's one of the actual ways how you can actually defend attack. Because 99% of all attacks use IPv4, and if for some reasons attack succeeds, you may have still officers over IPv6, because it's a little bit more complicated to attack. It's more complicated to generate enormous traffic using IPv6 protocol. It may be your chance to survive and to handle this attack in some ways. So deploy IPv6, and what inside of packets we have. So let's focus on IPv4 packet because they have way more fields and way more options how you can actually misuse them. So in IPv4 packets we have lots of fields like length, source IP, destination IP, we have fragmentation flags, we have TTL flags. And literally every single field can be randomized and used as attack vector. That's simple. But again, we are talking about the most complicated and most common attacks. So, and in most of the cases you will see fragmented traffic. Simple. Why? Because to attack your network, attackers need to generate serious amount of traffic against your network, which actually means that they need to use as much as possible large packets to attack your network. So typically, it's their main point to generate something at least 1,500 bytes in total payload, just to fill your routers and your upstream as much as possible. But in many cases, actually, software practices used to generate this kind of traffic, they lead to fragmentation because in general they generate way bigger packets, like few kilobytes. And just to send this packet over UDP protocol, it needs to be fragmented. So if you see abnormally high level of fragmentation in it, apparently something going wrong in your network. So it's one of the signs. It's most common type. If for example, we pick up like what is the most popular attack against fragmented IPv4 packets. And then let's move a little bit deeper. And when I say deeper, we are talking about UDP and TCP protocol. And again, TCP protocol can be used for DDoS attack. But again, most common one, it's UDP protocol. And be more specific, again, it's fragmented UDP packets. Because of many reasons, because UDP protocol is way simpler to use to generate malicious traffic, to generate it using an approach called amplification. So, in most of the cases, again, if you run TCP DOM during DDoS attack against your infrastructure, against your network, you will see plenty of UDP packets, and plenty of fragmented AP packets, and it may be signs of something going wrong in your network. Again, different protocols used for DDoS amplification. GRE protocol can be used. Again, it's quite unusual because on normal basis we don't work with protocol GRE on daily basis. And for software engineers or Linux administrators, like, what is that? Because we know ICMP, we know TCP, we know UDP, but what is GRE? And for network engineers, of course, it's very well-known protocol. It can be used for attack generation. And one of the main protocols, I would call it like workhorse of internet, it's a protocol called TCP, and unfortunately it also can be used for DDoS attacks. And this kind of DDoS attacks is one of the most, I would say, dangerous ones, because I'm going to talk about TCP SYN flood attack. And what is special about TCP SYN flood attack? What it makes it different from UDP? And in case of UDP, main point to fill your links. Simple. To generate as much as possible bandwidth and push it towards your network, and then fill your upstreams and provide no space for legitimate traffic, and this way just to disrupt your network. But what is the point? What is the problem with TCP SYN attack? Because again, on the contrary, in comparison to UDP, every single packet in the TCP SYN flood attack, it's very simple. It's around 60, a little bit more bytes each. Doesn't sound scary, just packet of 60 something bytes. It's nothing. We can simply stop it. And problem is we cannot. Because there are different ways how you actually can measure performance and peak of DDoS attack. And typically it's bandwidth based or packet rate based, and they're very different. So UDP amplification based attacks, they are mostly bandwidth based or volumetric. So point to generate as much as possible capacity, push it against your network, done. But in this case, packet rate will be quite small, because let's imagine about 1G link. For maximum potential number of packets per second on 1G link, it's 1.4 million packets per second. But if you generate something like 1,500 length packets, it will be way less, way less. Because assumptions that you can accomplish line rate on 1G only if you can generate something like 64 byte length packets, and you generate lots of them. But if you generate larger packets, you cannot reach line rate. But problem with line rate, because it's one of the boundaries for many network equipment, because not so many routers, they just cannot reach line rate. Because for 1G, line rate is simple, it's 1.4 million, done, simple. But for 10G, it's 14 million per second. And for 100G, it's 144 millions of packets per second, which makes it actually less than 1 nanosecond for a single packet. It's damn complicated to implement even in hardware. I'm not even talking about software. So this is a kind of attack may succeed. And in terms of TCP SYN flood, attackers plan to generate as much as possible packets to just push not only your links, your upstream on boundaries, like on their peak performance, and then to push your routers to their limits of scalability. And if attack against not your infrastructure, not your network, but against specific service, it will just ruin it. That's why it's very dangerous, and it's one of the most complicated attack types to filter out. So, and thank you for listening, and I hope it's simple to understand now that there are no magic behind DDoS attacks, there are no magic packets, there are no magic tactics. It's just simple packets, as exactly same packets as used for legitimate application, for like game servers, for VoIP applications, for DNS protocol, for BGP protocol, for HTTP protocols. But they implemented and crafted in a special way to generate as much as possible bandwidth, again, volumetric or bandwidth-based attack, or generate as much as possible packets per second, again, packet rate attacks. So, simple. Stay with us and wait for my next video to learn more about these attacks. Thank you.